Hi guys, my name is Chris and I'll be talking about similar triangles. So let's start with the definition of similar triangles. So two triangles are said to be similar if they have the same shape, which means that their corresponding angles are equal and their corresponding sides are in proportion. So we have three criteria that are used to establish similarity. The first criteria is the angle-angle rule. We have two corresponding angles that are congruent, like B and F, and A and E. Then we can say the two triangles are similar. Next we have the side angle side criteria or rule. So if two sides are in proportion, so that's AB in this case, and EG, and then we have AC and EF. If those are in proportion, and the included angles, which is like the angle in between, so that's A and E. So if those two angles are congruent and the sides are in proportion, we can say that they're similar. And lastly, if all three sides that are corresponding are in proportion, then we can say it's similar. So that's AB and EF, that's BC and FG, and AC and EG. So some things you want to look for in geometry problems. So always you want to look for similar triangles because they can simplify difficult problems. But you never want to convince yourself that triangles are similar because then you can make a mistake. But for example, imagine we have some parallel lines and they're cut by a transversal. We always want to look for parallel lines because, for example, we know that these are corresponding angles, so they must be congruent, and then these are vertical angles, so they must be congruent. Also, we can use alternate interior angles. They're just angles that are on opposite sides of the transversal that are sandwiched in between the parallel lines. So now let's take a look at a problem. That's 2001 AMC 12 problem number 22. Let's look at the problem statement. The problem says, in rectangle ABCD, points F and G lie on line segment AB, so that AF is equal to FG is equal to GB, and E is the midpoint of line segment DC. Also, line segment AC intersects line segment EF at H and line segment EG at J. The area of the rectangle ABCD is 70. Find the area of the triangle EHJ. So you have answer choices A, B, C, D, and E. A is 5 over 2, B is 35 over 12, C is 3, D is 7 over 2, and E is 35 over 8. So look at our diagram here. We have a rectangle ABCD, and we know that it has there's an area of 70. So first, let's prove some triangles similar. So there's two key observations we need to make, and they're both identifying two pairs of similar triangles. So first we need to start by finding that AFH, this triangle over here, is similar to triangle CEH. So in this case, we see that we have vertical angles here and here. So that's one pair of angles that we have congruent. And then, looking this way, we have parallel lines A, B, and C, D of this rectangle, and we have the transversal EF. Therefore, we have alternate interior angles, so these angles and these two angles are congruent also. So now we have two pairs of congruent angles that are corresponding in two different triangles, so we can say that these two triangles are similar. So we also need to find that another pair of triangles are similar. So erase the board. Okay. So you also need to notice that triangle AGJ, you notice that this triangle is similar to triangle CEJ. Again, we have vertical angles here, so those two angles are congruent. And then we can use these two parallel lines A, B, and C, D again. And then we have the transversal EG this time. So now we can notice that these two angles are congruent because they're alternate interior angles. So now we can use the AA rule again of triangle similarity. So we can say that these two triangles are similar to each other. Okay. So now we conclude that triangle AGJ is similar to triangle CEJ, and also we can say that triangle AFH is similar to triangle CEH. Alright, so what does this tell us about the triangles? Well, we can use the similar triangles to find ratios now. So we know that triangles AFH here and CEH are similar, so we can say that their corresponding sides are in proportion, which just means that AH over here and HC over here are in the same proportion as AF over here and EC up here. So we can write that statement here. So now, since AB is divided into 3 equal parts, AF we can say is 1/3 of AB. So AF is equal to 1/3 of AB. Alright, so we can also say that since E is the midpoint of DC, E is right here, is the midpoint of DC, we can say that EC is equal to 1/2 of AB. So now we can relate AF and EC. So we know that we can write them in terms of AB. So we have that AF over EC is equal to 1/3 over 1/2. And simplifying that gives us 2/3. So now we can also say that AH over HC is equal to 2/3. So I can just write that over here. So let's move that to the top left or top right corner. Okay, so now we know that from the similarity triangle AGJ and similar triangle CEJ, we have that AJ over JC is equal to AG over EC. So what does this mean? We know that AG is 2/3 of the line segment AB. And we also know that EC is 1/2 of DC. So this time we can say that AG over EC is equal to 2/3 over 1/2. And simplifying gives us 4/3. So this time we can write that AJ over JC is equal to AG over EC, which also is equal to 4/3. Okay. So now we can find the area of triangle EHJ. So we can find this area EHJ by subtracting the remaining areas from triangle ACD. So we need to subtract AHD, HDE, and EJC. And we want to leave behind EHJ. So we have these ratios now, so we can compute each individually. So we know that ACD, the whole thing, is 35 because that's half of the rectangle. And the rectangle is 70, so times 1/2 is 35. Let's start by writing 35 over there. So we know that AH over HC is equal to 2/3. So we have AH is equal to 2/5 of AC because AH plus AC is equal to the full diagonal AC. Yeah. And then since triangle AHD shares the base AD with triangle ACD, and its height is scaled down to 2/5, its area is scaled down accordingly. So that's 2/5 times 35 is the area of AHD, which is just 14. So you subtract 14. So the area of triangle DEH is next. So segment DE is half of DC because of the given statement. So that's E is the midpoint of DC. So the height from H is also 3/5 of the total height. Yeah. So the area of DEH is 1/2 times 3/5 times 35, which is equal to 21 over 2, or 10.5. 10.5. So next we need to subtract 10.5. Okay. Now, the last area we need to find is a area of triangle EJC. So from similarity, JC is equal to 3/7 of AC, because we found this ratio over here. So because JC is 3/7 of AC, JC is 3/7 of AC, then the triangle EJC is 3/14 of triangle ACD. So you have triangle ACD, and we have the triangle EJC. EJC. Okay. So doing that multiplication is 3/14 times 35 is equal to 7.5. So that's the last thing we need to subtract. And so doing this subtraction, we find that this answer is equal to 3. So let me clear the whiteboard now. And so the answer is 3, so our final answer is going to be answer choice number C.